Alright, let's focus on this chapter on time value of money. Okay, here this goes with a simple concept that a dollar today is always worth more than whatever the dollar we have in future. Because today if I have $1 with me, I can probably deposit it somewhere which will make it slightly more than that $1 even after one day. Right, it will be worth slightly more than $1. So whenever we use the concept of time value of money, we are more focusing on that interest during that period. The interest generated during the period becomes a crucial part, and that too, whenever we use in finance, we use the interest as a compound interest. Simple interest is something which is beyond the regular usage in finance. So we always talk about compounding, right? So the interest, because of the addition of the interest, what typically happens is whatever is 1 rupee worth today, it may go to 1.5 rupee worth after some time, or even 1 rupee 5 paisa worth after some time, right? So which means if someone says that you will get $1 after 1 month versus $1 today, I would always prefer the $1 today because it would be equal to $1 plus something in the future. So that is the entire concept of time value of money. So probably whatever in our schooling days also, we must have used the formulas like compound interest, the amount with a compound interest and all that stuff, which is again a reflection of the time value of money itself. So starting in this chapter, we are simply starting off with the concept of interest rate. There are different forms in which this term of interest rates is being used. One, primarily as our investment, the return which we get on our investment, that's an interest rate, because if I deposit 100 today, I get 110 after 1 year. That 10% which I am getting is what we call as interest rate itself, right? So interest is used in the context of the rate of return. One, two, it is used as a discounting rate. Discounting rate is nothing but if I am going to get 100 after 1 year, how much should I deposit today? So it is a present value of the future earnings or future cash flows. The discounting rate is nothing but the rate at which I discount the future value. See, when I say the present value, from the today's deposit amount, I find out the future amount, which is nothing but the compound interest. So something that is getting compounded and I am getting a value, the interest rate I am using in that context. But if I look at it from future, if I get something, let's say $100 in future, how much do I need to deposit today? That is where I am calling the word as discounting. The future value, I make an equivalent of the future to the present, right? That rate at which I am bringing it down to the present value is called as a discounting rate. Even that, for that purpose, we use the interest rate itself. So the interest rate can be used either for compounding, for finding your rate of return on investment, or for discounting, which is the future values bringing them to the present value, or three, the most important aspect, the opportunity cost. Let's say I want to withdraw my money from the bank, right? I want to withdraw my money to probably buy something. Now, by doing that, I have foregone some interest which I would have got if I have kept that money in the bank? Right? So that foregone amount is nothing but again an interest rate itself. So in that context, interest rate is being used as opportunity cost, because I have lost out on an opportunity to earn something more by withdrawing the money from the bank. Let's say I have withdrawn 50,000 bucks to buy a TV. If that 50,000 bucks was there in the bank, probably I would have got probably 51,000 or 52,000 after some time, which is because of some interest. But I have foregone that amount because I have withdrawn it. So in that context, the interest rate is being used as an opportunity cost. So there are three different forms in which an interest rate can be used. In all these things, whatever we are using as a mode of converting from the present to the future or future to the present or something foregone is nothing but the interest rate itself, but it is playing a role in different forms in different contexts. And how is this interest rate typically determined, or what are the components of this interest rate? So it all starts with the real risk-free rate, which is generally does not exist. It's a theoretical concept. No instrument exists with this concept of real risk-free rate. It's nothing but on a risk-free loan, zero risk loan, without taking the impact of inflation, whatever is the return I can get, that is what I call as a risk-free and real. Real means it does not include the impact of inflation. Whenever we use, wherever, in whatever context we use the word real, it does not include the inflation. It excludes the impact of inflation. Whenever we use the word nominal, it includes the inflation factor. Two things. So real risk-free rate is mostly a theoretical concept, because inflation is a part and parcel of every return. So without inflation providing a return, it's very difficult to have a security existing in the market. So it's primarily a theoretical concept. Whatever the return we are getting on a completely risk-free security without even taking the impact of inflation. But if I add the impact of inflation to that real risk-free rate, I will get the nominal risk-free rate. That is what is at least a risk-free which only includes inflation, which means risk-free is probably a security which cannot default at any point in time. The ideal ones are government securities. Government securities generally they don't default. Government bonds, treasury bills. So anything which is issued by the government, they generally don't default. So they are considered to be the highest risk-free kind of securities. And the rate, whatever the return they give, 4%, 5%, 6%, whatever is the return they are providing, is the nominal risk-free rate of return, because it includes inflation. Right? It's not a real. It includes the inflation part, and that is the. So if I remove, let's say from that 6%, I remove, let's say, inflation of 5%, and which means 1%, that is the real risk-free rate of return. For all practical purposes, we cannot use that real risk-free rate of return. We use that nominal risk-free rate of return itself, at least which takes care of the inflation. So in a particular country, if the inflation is very high, we see that the nominal risk-free rate of return, the return on the government securities, will be much higher, and where the inflation is very less, we see that the government securities give much lesser return itself. So the better is, so typically speaking, nominal risk-free rate of return is equal to real risk-free rate of return plus expected inflation factor. But for all practical purposes, sometimes Instead of a simple addition, people look at it as this is the exact relation. Instead of simply adding this, they say 1 plus nominal risk-free rate of return is equal to 1 plus real risk-free rate of return into 1 plus expected inflation. The same stuff in terms of a multiplying, instead of arithmetic, they look at it as a geometric concept. Right? But for a quick calculation, if at all I need to quickly calculate the impact of inflation or something, we can simply do that addition kind of a form also. Very rarely you will have a question which will have both the answers. In the exam, the purpose is not to test out between these two, at least. So the question could be either more favoring the first formula or the second formula. Either of them is a correct implication itself. But the first one is easy to calculate whereas the second one is slightly difficult, but it is correct, exact kind of a relation. Okay, now apart from risk free, let's say I want to invest in some company's bonds, ICICI bonds, corporate bond. Now it may not be as risk free as a government security. It may be more risky because probably if that particular company defaults, there is a scope that that company may default, which means there is some chance that I may not get my money back. So there's some risk. Now what are the components of the risk? There are 3-4 components that initial are talked about. There is a default risk, which means that company, because government is more secured compared to a private organization. So there is some amount of risk. So they may default. They may go bankrupt. They may default. So there will be some chance. So whatever is that chance, because of that there is an extra risk that is getting built up. So it's not a risk free. There is one more risk with respect to liquidity. Can I surrender my bond anytime I want? If I want to sell it, are there buyers for it? Is there any active secondary market available for selling it? That is what to do with the liquidity. The moment I want to sell it, will there be a buyer available? Can I transfer it so easily? That is what is a risk, that in some bonds I may not be able to sell at all. So which means there the liquidity is a very big risk. And the third major one is the maturity. The long term bond, 10-year bond, which means I cannot withdraw anything in the next 10 years. Right? I am lending it for a 10-year period. I cannot withdraw anything in the 10-year period. Maturity is a 10-year maturity, which means whatever the amount I have invested in that bond, I'll get back only after the 10th year, which means I have blocked my money for the entire 10-year period. The longer the maturity is, the higher the risk which I am taking. The longer the maturity period, I am taking a very high risk. So even there, a maturity risk is forming a big problem. So these three risks, the liquidity, the default and maturity, are the extra risks associated with the securities, which means the higher the risk, the higher should be the return. So if at all, let's say the nominal risk-free rate is around 6%, probably when I add something, default risk premium, maturity risk premium, liquidity risk premium, for that particular bond or for that company, probably it may go up to, let's say, 10%. So that is how the interest rate on this bond is getting calculated. It will take into account all these things, right? Initially, nominal risk free is around 6%, but because this bond is slightly more risky, because of default risk, because of liquidity risk, and because of maturity risk, it has to give slightly more return than the nominal risk-free rate of return. So that more return is coming out as an extra premium in each of these things, which is finally boiling down to around 10%. Right? Yeah. Now, in this we'll discuss about a topic, effective annual rate. See, sometimes when we are getting the quotations, or when we look at our bank deposits also, they do not do the compounding annually. Sometimes the compounding happens quarterly, sometimes it happens monthly, half yearly, all kinds of things happen. But whenever they use an interest rate, that interest rate is actually called as a stated or a nominal interest rate, which will be always annual. So they may very well say, we are giving a 9% interest rate on this deposit. That is a stated rate. 9% 9% interest rate on the deposit is a nominal rate or a stated rate or a quoted rate. But effectively, it is not 9%. What it translates to the end investor is actually not 9%. It will be equal to 9% if the compounding happens annually. If the compounding also happens annually, then both of them are same. But if the compounding happens, let's say quarterly, it will be much more than 9%. Probably you may get it as 9.5%, 9.3%, whatever. But it cannot be 9%. Only if the compounding happens annually, it will be equal to 9. So, banks or any of them, though they quote that the interest rate is 9% or 9.5%, you will be getting more than that 9 or 9.5. That's where they use the term also effective rate. Effective rate is what exactly translates to you because of the compounding frequency. The nominal rate, they have to quote it as 9 or 9.5 as fixed. But depending on the frequency of compounding, the value which you would be receiving would be higher. That is what is the typical concept of effective annual rate. Now let's say the same 9%, if I say is compounded half yearly, right? So, which means per every half year, it is 4.5%, right? 9% per year, 4.5% per month, per 6 years, per 6 months. Then my final value will become 1 plus this 4.5% to the power 2, which is 2 6-month periods. So it is compounded. After 6 months, whatever I am getting, it is compounded for 1 year. So I am actually getting 1.0920. Probably if I have to convert it into percentage, I will subtract 1, which is giving me 0.092, which means in effect I am getting 9.2% interest. Though the stated rate is 9% only, but because of the compounding frequency, it is becoming 9.2% for me. Right? So, simply put, this is how I go ahead with my effective annual rate. 1 plus the stated annual rate. In our example, it is 9% is the stated annual rate, divided by how many periods in a year. Semi-annual means there are 2 periods in the year. So I'll divide by 2 and also do a power of 2. The same 2, I'll use it for division. Let's say quarterly. I'll divide by 4 raised to the power of 4. Minus 1 is what will give me my effective annual rate, because the compounding is not happening in 1 year. It is happening every quarter. So every quarter the value is becoming higher and higher and higher. So overall at the end of 1 year, I am getting much more than when the compounding is happening at the end of 1 year, because every quarter a compounding is happening. So after every quarter I am getting something extra, whereas in case of annual compounding I am getting the first interest only after 1 year, whereas in quarterly compounding I am getting the first interest after first quarter, and on the top of that there is one more compounding that is getting happening. So that's where in effective sense, I'll get something more. That is what in our case, the 9% annual is same as 9.2% if it is semi-annual compounded. Similarly, if I am doing a quarterly compounding, it will be even more. Right? Probably if you try out the quarterly compounding, 1 plus 9% divided by 4 to the power 4 minus 1. This is coming out to 9.3%. In case of quarterly, it is coming out to 9.3%. Similarly, monthly, it may come out slightly more. So it keeps increasing. Right? So that is what is the effective annual, which means in a yearly period, effectively what is the return I am getting. So we should be very much clear about that interest rate which is used. Is it a nominal or a quoted or a stated interest rate, or is it an effective annual rate? Because from an investor's standpoint, he is more bothered about the effective annual rate rather than the quoted rate, because effective annual rate is the amount which he is getting actually. But as per the methodology of these banks or all, they will have to mention only the quoted rate. Mandatory to mention the quoted rate or stated rate, but along with that they can publish the effective annual rate, but they cannot directly talk only in terms of effective annual rate. So that's where you will see both of them, and we should be comfortable in converting the quoted rate into an effective annual rate. And the same way, let's say if we are doing monthly compounding, probably the number may go up even more. Right? In case of monthly compounding, it becomes 1 plus 9% divided by 12 to the power 12 minus 1. This becomes 9.38. So it is going down, up and up and up, but slightly at a decreasing rate. Right? For semi-annual, it was 9.2. 9 to 9.2. Almost 0.2 gap. Semi-annual to quarter, it has just become 9.3. Only a small increase. Quarter to month, it just increased by another 0.038%. So it is increasing, but it is increasing at a decreasing rate. Right? And if at all the compounding frequency is daily, which means I have to make it divide by 365 to the power 365. That is a daily compounding. Now hourly, minutely, secondly. Now if it comes into very, very minute intervals, where the compounding frequency is instant compounding frequency, that is what we call as continuous compounding. Where the compounding frequency is too large. Now if I say daily, we said divide by 365. Hourly, probably I have to divide by even more a bigger number. Minutely, even more a bigger number. So if that number which I am dividing it is extremely large, right, we call that as continuous compounding. And in case of continuous compounding, this will boil down to not 1 plus r by m to the power m. Instead of that kind of a model, it boils down to e power r minus 1. Right? E power r minus 1, which is r is the annual rate. So let's see, in our case, e is the exponential stuff, which will become 9% is the annual, right? E power r. R in the case, we take it as a annual stated rate minus 1, which will give me 9.41. So the continuous rate of return is 9.41%. Continuous rate is like a very minute compounding. Monthly compounding has given 9.38. Probably daily would have given 9.4 or something. Even a lesser, continue. So it's a limit. It actually limits to this value, even if it is continuous compounding, which is the minutest possible. My effective return is 9.41%, which means the 9% stated at the max can give me an effective return of 9.41%, and that too when the return is continuously compounded. It can never give me a return of 9.5%. The maximum that is possible is 9.41%, only when there is a continuous compounding in the process. Fine? And of course, there is one more term to talk about, which is nothing but annual percentage rate, which is nothing but a simple multiplication, no effective rate. If I say monthly interest rate, sometimes we see the quotes, especially by these gold loan companies. They say 1% per month. 1% per month. If I have to compound it as an annual, effective annual rate, right, it will be to the power 12 is what I have to do. So if I have to say, if someone says 1% per month, the annual rate for me becomes 1 plus 1% to the power 12 minus 1. So this becomes 12.68%, because there is a continuous compounding, monthly compounding that happens. So the effective annual rate is 12.68%. But when I say annual percentage return, APR, annual percentage rate of return, APR, it is nothing but 1% into 12, where I simply multiply it to make it annual. Right? Whereas when we talk of effective annual rate, we bring in the concept of compounding. Effective annual rate across the term effective annual rate uses the concept of compounding to derive at your rate. Right? So these are some of the stuff. If the stated annual rate is 8%, find the EAR for semi-annual, quarterly, monthly, continuous, which we have done just now. Instead of 8%, we have taken 9%. But the whole funda goes with that EAR is nothing but 1 plus whatever is your nominal rate or quoted rate divided by number of periods per year to the power of number of periods per year minus 1. That will become your effective annual rate in the process. So for semi-annual, M will become 2, for monthly it will become 12, and so on. Now the next thing is talking of a few numericals more focused towards finding the future value and the present value of the money. Future value is something which I am depositing today, getting something in future. So how much should I get in future is what is talking of the future value. How much would I get today is what is talking about the present value. These are the two things. So something I deposit today at some rate of interest, how much should I get? And something I am getting in future, how much should I deposit today? That is the present value. So in any simple concept, present value boils down to the amount which I am receiving or paying today Future value refers to the amount receiving or paying sometime in future. That future can be tomorrow also, or after 1 hour also, or it could be after years, anything which is not immediate. Now, in that, the first section of questions are more on single lump sum cash flow. I deposit something today, how much will I get in future? Or I'll get something in future, how much should I need to deposit today? It's a single lump sum deposit or lump sum withdrawal. So regarding that, it is nothing but this is same as our compound interest formula of the childhood. Or in our simple case, we can very well go as future value is equal to present value into whatever 1 plus interest rate to the power n, number of period. Depending on if this interest rate is annual rate, this will be in years. If this is a quarterly rate, this will be in quarters. Right? If this is an annual rate, this will be in years. This is a quarterly rate, this will be in quarters. That's a simple logic. And of course, in our exam, we can simply go with a financial calculator, which actually has the buttons for PV, FV. The interest rate is actually denoted as I by Y, which is interest per year. Then there is number of periods. And then there is a PMT, which I'll talk about slowly, which is annuity. So these 5 buttons will be there as a part of our financial calculator. So just keying in the values into this financial calculator, keying in 4 values, I'll get the 5th value. I can compute the 5th value. That's how the financial calculator calculations work. And from your exam also, no other calculator is allowed into the exam hall. You have to carry a financial calculator itself. So in that, obviously, these 5 buttons are there, where you can key in 4 of them and you can get the 5th one. So the process of calculating and all, probably you need not bother too much, because the question would be given and you have to solve and give the answer. So probably you may not use this formula of FV equal to PV into 1 plus R to the power n, because all you need to know is identify what is PV, what is FV, what is R, what is n. So once you are able to identify them and key them appropriately into the calculator, you can get the computation much easily. Once all of you get the calculator, we can repeat these kind of questions once again. Right? Today I'll try to solve them, giving you a conceptual perspective of that. But once you are, all of you get your calculators, we can very well plan out one session on the usage of the calculator itself. Right? Because that's something which you have to plan out as early as possible, so that you can get some kind of a grip on the usage of that calculator also, because that plays an important role in the exam. All right. So let me start off with a couple of numericals on this, so that we can correlate these two much better to start with. So in this itself, if I rearrange, then PV will become FV divided by 1 plus R to the power n. Whatever is the future value that is talked of, I divide it by 1 plus R to the power n, I'll get the present value. Now let's look at a couple of small numericals on this. So this is like your future value calculation, because I'm talking of depositing something today at some interest rate. I want to check how much will I get after 3 years. But here 8% per year, that's a quoted rate, and he is saying it is compounded quarterly. Either two steps. First, convert the quoted rate into an EAR, effective annual rate, and do the problem in years. Or let the rate be directly in quarters. That's where I did. I divided it by 4, which means I'll take, for all practical purposes, I'll take the rate as 2%. And the period, I'll not take it as 3 years, I'll take it as 12 quarters. Right? So typically when I go back to solving this question, I have 3 things. I have PV, I have rate, and I have, which is nothing but I by Y, and I also have N. PV for me is, okay, from your calculator standpoint, you can directly enter 2000 as the PV. From an Excel standpoint, I'm entering minus 2000. That's, I mean, you don't need to bother about it, because from a calculator standpoint, 2000 as an entry will suffice for PV. Now the interest rate, I'll take it as 2%, because there is a compounding quarterly. And the number of periods, I'll take it as 12, because there's a compounding quarterly. I cannot take the data in years. I have to take it in quarters itself. Now from here comes my FV. So you can enter these 3 and simply say compute FV. There will be a button called compute. Press compute and then FV. You will get the future value. Now in this case, if I am trying to compute it, I will get it typically as, so this will be my future value, which means if I deposit 2000 today at 8% per year, quarterly compounded, after 3 years, I'm going to receive 2536 rupees or dollars. Right? So this is a future value of a single lump sum, which means I have deposited 2000 today. How much will I get in future? Then similarly, look at the next one. So there is a monthly compounding, which means the interest rate also should be made monthly, because the quoted will always be per year. The quoted will always be, or should always be, per year. So I'll have to convert it into monthly first. The years, convert them into months, and then use them for the calculation purpose. So FB is 10,000 for me, right? Then N is 60 months, because I have to convert it into months, and the interest rate probably 10 divided by 12. It's around 0.8%. 10% divided by 12, 0.8%. Now this is what will be my PV. This will go as my PV, which simply says I have to deposit 6,077 rupees today at 10% interest, monthly compounded. After 5 years, it will become 10,000. So I need to have 6,000 today, so that I can get 10,000 after 5 years. So this is the present value of a future money. Again, this is also a lump sum. Single. I am going to withdraw 10,000 at a stretch. So there is no periodic payment in this processes. No installment payment, no periodic payment. Everything is one single lump sum, either paid or received. So in that case, I'll go with the simple PV and FV kind of stuff. Now, yeah, the third one, just for a quickness, given a discount rate of 8%, which is rate is 8%, PV of $5,000 to be received after 3 years. This is a straightforward problem. FV is 5,000, N is 3, no issue of compounding here, no compounding problems because it's an annual compounding. So I don't need to bother about converting it into months or year, quarters or anything. It's a straightforward problem. Now, so that's the first type of problems where there is a single lump sum amount either deposited or received either today or sometime in future. Now the second series of problems go with annuity, where the payments or the receipts, either of them, they are a series of payments or receipts at equal intervals and equal amounts. So there is a series of payment of equal amount done at equal intervals of time. I call them as annuities. Payments or receipts. The better examples will be like our EMI. They are a series of payments. We'll do them at equal intervals and equal amounts. Similarly, probably the premium payment on an insurance policy. Equal interval, equal amount, series of payment. All these three should be applicable. The interval should be a key thing. They should be of same spacing. It may be every month or every 3 months, whatever it is. But equal spacing should be there between the payments or receipts. Equal amount should be there. And it should be a series of payment. Then I will call them as annuities. And in these annuities, again there are two categories for me. One is an ordinary annuity, or sometimes even people call it as regular annuity, which means the payments or receipts, that series of payments or receipts happen at the end of the period, not in advance. They are done at the end of the period. For example, loan also, the first month EMI I'll pay at the end of the first month loan. Today I take the loan, I'll not pay anything today. I'll pay my EMI at the end of the month. Right? Which means at the end of the period, I pay or receive. We call them as regular annuities. And if the payment or receipt happens at the beginning of the period, like advance, the house rent which you pay, it's an annuity at least for 1 year. Same amount, same interval, series of payments. Probably at least for 1 year until the house owner does not increase the rent, it can be treated as an annuity because it should have these features. Equal amount, equal intervals of time and a series of payment. There we are making the payment at the beginning of the period, not at the end of the period. So they are called annuity dues, where the cash flows occur at the beginning of the period, and if the cash flows occur towards the end of the period, we are calling them as ordinary or regular annuities. And in the formula, it is handled through a button called PMT. PMT will take care of whether it's an annuity payment or not. right? So if something is an annuity, I identify something as an annuity, then I will treat it as a part of PMT. So I'll key in as a part of PMT when there is a regular series of payment, right? It will be keyed in simply as a PMT there. Okay. So now we'll try to take up a few numericals. So there also we can talk about future value and present value. So let's look at again a few numericals. Look at the fourth one. If I deposit $1,000, it's not a lump sum deposit. I am at the end of every year. So I am depositing it as a recurring thing for 10 years. And the investment returns 10% per year interest. What is the future value? So what are the numbers I have here? This 1000 will actually become my PMT because it's a repeated payment. Whatever the amount which I am paying repeatedly for a certain period, I'll call it as a PMT, and this will become my N, and this will become my rate. So I have to find out the future value. These are the three inputs I have. Because there is no lump sum payment that is happening, probably my present value is 0. Present value is whatever lump sum I am depositing today, which is not existing. So I can take it as 0, which means 4 variables are there. I have to just find out the fifth variable. In almost all the time value of money problems, the question, whatever complex it is, you may have to break it into 2 or more small questions. Right? I have taken one complex question towards the end in this chapter. You have to break the problem into 2 or more problems if required. But for each problem, you will have to identify 4 of these 5 parameters, and the fifth one will be computed. The simple way using the calculator, forget about the formulas associated or driving it. That's where intentionally I did not even list down the formulas for finding out the annuity, because you can very well handle them through the calculators. So there you need to identify the four variables, and the fifth one is automatically computed. You can just say compute and press the fifth button, which will give you the calculation. So in this case, so I have a PMT value. I have a PMT because I am depositing. Okay, for all practical purposes, whenever I deposit, I'll put it with a minus. Whenever I receive, cash outflow is represented with a minus and cash inflow is represented with a plus. So I am putting a minus 1000 here for 10 years because there is no compounding funda here. So I can take fully in years itself, and even the interest rate I can take it as 10%. So I just need to compute the future value. So all these thousands as a lump sum become how much at the end of 10 years. So here if I look at it, it becomes 15,937. 1000 every year, probably for 10 years, and each of the 1000 accumulates interest. So the first 1000 accumulates interest for 10 years. The second 1000 accumulates for 9 years. The next 1000 for 8 years, and so on. So when I include all those things, at the end of 10 years, my money is going to become 15,937. This is what we are calling as a annuity. Now if I want to find out the present value of that, if I am depositing 1000 after every year, what is the present value of all those payments? I can use the PV formula here. PV, where this time the interest rate again is this much, the number of periods and PMT. So there is no difference between depositing 6,144 today versus depositing 1,000 every year for 10 years. Both of them are same. That is what it means. See, these three are one and the same. Either deposit 6,144.57 today, one time, or deposit 15,937.42 after 10 years, right? Or deposit 1,000 every year for 10 years. All three are one and the same. Probably when you are looking them in real number terms, you are seeing they are all different. Where is 6,144? Where is 15,937? And where is 1,000 for 10 years, which is 10,000? If there is no interest factor at all, probably these three are looking like three different numbers. Now, when I bring in the concept of interest and time value of money, for me, these three are one and the same. 6,144 today is same as 15,937 after 10 years, which is also same as 1,000 per year for 10 years. All three are exactly same. Right? So I should not be anywhere indifferent between these three numbers, as long as the interest rate is 10%. All three are one and the same for me. So that is where the compounding becomes actually a very key thing. Because you see here, 6,144 today is equivalent to 15,937 after 10 years. Right? Which probably another 10 more years I keep, it would become 4 times or 5 times the original money. Just with 10, in that process, all we are getting is only 10% return. Nothing more than that. Right? So, this kind of clarity, if it is there, almost all kinds of finance problems can very well be solved, because anything to do with the investment is playing around only with these 5 fields. Only with these 5. Right? Now we look at the PV we have already seen. Okay, probably this is slightly different. What is the PV of $4,000 end of the year payments? If the first payment is to be received 2 years from today. So basically, if I try to draw a small line, I suggest for some of the complex problem, you try to draw a timeline. Because here the payments are not happening at the end of the current period. Right? So, probably today we are at 0th year. At the end of second year, third year, fourth year, and fifth year, I am receiving 1,000. This is what the problem is saying. I am going to receive 1,000. Is this how the problem is? $4,000 end of the year payments, end of the second year, end of the third year, end of the fourth year, end of the fifth year. These are the payments that are coming out. If the first payment is to be received 2 years from today, end of the second year is like 2 years from today only. Now, and the rate of return is 9%. Now, I cannot consider it as an annuity right from today, because there is a 1 here and here the cash flow is 0. It's not equal amounts, equal intervals of time. Probably if I break the problem and look at it only from here, then I can treat it as an annuity. Equal intervals, equal amounts, right? So if I just switch myself to 2 months after, 2 years after, I am moving to from today to 2 years after, then how do I reframe the question? I am receiving 1000 today. If my today is 2 years after exactly, so I am receiving 1000 today, 1000 after 1 year, 1000 after 2 years, 1000 after 3 years. Equal installments, equal time periods. So I can treat it as an annuity. But because the payment is getting received at the beginning of the period there, I will treat it as an annuity due. Or problem wise, I will shift myself here. I can shift wherever I want. I will shift from there to here. Then how my problem is becoming? Then also it's an annuity. Because at the end of 1 year, I am receiving 1000. End of 2 years, another 1000. End of 3 years, another 1000. End of 4 years, another 1000. So I can find out the present value at that period. Right? So let's say I'll do the second one, where I am shifting myself to 1 year later to create it as an annuity. First of all, I want to create this as an annuity. So I am shifting myself to that location. So there the PMT is minus 1000. The number of periods is 4 years. Correct? The number of years is 4 years. 4 equal payments. And the interest rate is 9%. Now from here I can find out the present value. So the present value is coming out as this, this and this. So the present value has come out as 9%. The present value has come out as $3,239. Right? So the 4 1000s in future are equivalent to 3,239 at the end of 1 year. But I want present value as of today, which means that will become the future value. Lump sum. That 3,200 and something is the lump sum future value, because it was a lump sum present value for all the future from there. So from today if I look at, it will become the lump sum future value. So the problem, there is a second problem that is getting created now, where this will become the future value. Time period will become 1 year. The interest rate will still be 9%. In this case, I'll have another present value calculated, because this number is in turn becoming a future value for the second internal question. Getting this? So any big problem, I have to break it into smaller problems so that I can solve them much easily. And at the end, I don't have anything more than these 5 fields. So I have to make sure that my problem is broken up in such a way that it falls within the scope of these 5 fields, and I may trigger 2-3 sub problems out of it to solve that entire problem. That's the beauty of time value of money problems. right? There's nothing more. Conceptually, only 5. But the problem can be created to any complexity. Especially the whole world of financial planning works exclusively on this concept. Wealth management works exclusively on this concept. So it's a very simple concept, but the problems can be of any level of complexity in this. Right? I'll take up one complex problem also, slightly complex, because CFA does not test on too much complex kind of a problem. So we just need to be logical in terms of understanding of these stuff. Alright. So here I'll go with PV. This time my rate is this much. The number of periods is this much. Then this will become my FV, which says the present value of all that stuff is equal to 2972 as of today, which means actually we have done it as 2 problems. One for year 1 to year 5, where we have made it as annuity. Year 0 to year 1, we have treated it as a single lump sum. So that kind of problem solving should really help us in solving a majority of these questions with ease. So that's how the annuity plays a big role. Another annuity question. Find the future value of an annuity that pays 500 per year at the beginning of the next 4 years. Commencing today, which means the first payment is happening today, which means it's an annuity due. Right? It's not a regular annuity. It's an annuity due. Now, from your calculator standpoint, the default always executes the annuity as regular annuity itself. There is actually a status where you have to set the calculator mode to begin mode. Then only it computes the annuity due. Otherwise, it will by default compute. When whatever you enter in the PMT, it will by default compute the regular annuity itself. So the settings wise, wherever the question comes on annuity due kind of a question, you have to make sure that you are setting the status of your calculator or mode of your calculator into the begin mode, which will actually give you the annuity due. Otherwise, for all practical, because most of the times we work in a world where all the payments or receipts are at the end of the period itself. Regular annuity. So the default settings are always for regular annuity. Even in Excel also they are for regular annuity itself. But if I have to go for an annuity due, I have to make this small modification. So in this case also, okay, I am depositing 500 every year for 4 years and interest rate is 9%. I need to find out the future value of, see, I'll show you for a regular annuity as well as for an annuity due, both of them. We'll see the difference, how that number changes. So if I am computing it for a regular annuity, which means the payments are made at the end of the first year, second year, third year, fourth year. Whereas in the due, beginning of the first year, beginning of the second, beginning of the third, beginning of the fourth. All of them are accelerated by 1 year. All payments are accelerated by 1 year. So the value will be much higher in case of, because they are deposited for a longer period. They earn interest for a longer period because you are depositing all the payments 1 year ahead. So the interest they carry will be slightly more. So if I see if it is a regular annuity, I am getting 2286 after 4 years. But if it is an annuity due, the same number will be worth This, oh, sorry. The same number will be worth 2492. So that extra of almost 200 is just because we are depositing all the payments 1 year ahead. So, depending on whether the question is annuity due or regular annuity, our answer changes, right? Because all of them are accelerated by a slightly 1 year ahead schedule. Even the PVs are also like that only. Even in case of PV, you will see that there is a difference in case of regular annuity versus annuity due. This is the PV for a regular annuity, whereas in case of annuity due, annuity due, it is becoming 1765. So, in both in the case of present value or future value, the annuity due will have a higher value compared to the regular annuity. So, we have to be very careful while solving the question whether it is of annuity due or a regular annuity. And the next thing in this case is perpetuity, which is nothing but an infinite annuity. So the annuity is not for a 5 years or 3 years or something, forever. Generally, in case of dividends, company pays a dividend forever, as long as the company exists and as long as your investment exists. There is no fixed maturity periods and all. Right? If you are a preference stockholder, as long as you sell off your equity stake, you will get the dividends. So in some cases, there are infinite payments for a longer periods. I mean, it's not a fixed period, very large period, or probably there is no end. Right? Literally, virtually there is no end. In those kind of things, especially like dividend. See, when I say a bond, then it will have a maturity period. When I say a loan, it will have a maturity period. But when I say an equity stake in a company, there is no maturity period to it unless the company winds up its business. Right? So that way, it's an indefinite or infinite kind of. If the company says, we'll pay you fixed amount every year. Fixed amount every year. It is qualifying as an annuity because equal intervals, equal amounts. But the time period is not existing in this case. It is forever. Then we classify it as a perpetuity. And for a perpetuity, we actually don't have future value because I don't know what is infinite. I cannot calculate the value of the perpetuity after infinite years. So there is no future value in case of a perpetuity. Only a present value exists. So present value in case of perpetuity is very simple. It goes as whatever is that fixed amount, whatever is the amount which we are paying every period, divided by the rate of return. That is what is the worth of the perpetuity. Because it's an infinite series, actually it is derived from the sum of infinite terms of a geometric progression. So the conceptual aspect behind that is the sum of infinite terms of a geometric progression. But from a simple understanding standpoint, it works out to A by R, where A is the amount which you are paying or receiving every period, and R is that periodic interest rate. Now let's say you look at the next question. Find the PV of a perpetuity with a cash flow of $10 every year and annual interest rate of 9%. So I'll simply calculate it as $10 divided by 9%. which may come out to some 11 or 12 or whatever it is. That is what, or it may come out to slightly more. $10 divided by 9%. This is coming to 111. So the present value of all the future cash flows which I am going to get, if at all the company is going to give me a dividend of just $10, just $10 forever, no increase in the dividend or anything. If it is going to be a constant dividend of $10 every year, the present value of all those amounts is equivalent to 111 today. So that's where this mechanism is used even for a valuation purpose. I am ready to pay 111 today to purchase the share of this company. Because all benefits which I am going to get, as long as I hold the share of the company, all the benefits whatever I am getting in future, I find out that today's value of all those benefits, it is coming to 111. So at the max, I am ready to spend 111 to purchase that share. I cannot spend anything more than that. Then my spending will be more than what I am receiving. Right? So this concept of perpetuity will be used very heavily in the valuations world, both in our equity and fixed income. When we deal with that, we will be dealing with these kind of questions where again the same concept of perpetuities and all will come up. So which are again having a lots of applications in the valuation world. So just getting a grip on the usage of this perpetuity becomes a very important stuff. Then look at the next. Sometimes we may not have any kind of a pattern in the cash flows. Right? See, if it is equal amount, equal installment and all, we can treat them as annuities and we can do the calculations. But if they are mostly uneven like this, some numbers like this, then it's better to handle either as each as a separate cash flow and then add all the PVs separately, or this itself again in our calculator we have an option of NPV, which is the net present value. The net present value of all these future cash flows. Right? So I can enter all these future cash flows one after the other and I say compute NPV. So which will again here the time period should be equal, at least. Spacing should be equal. Otherwise you have to enter zeros in those spaces. If the spacings are not equal, you have to enter the zeros in those spaces. Otherwise, like here there is a 0 after time period 3. If he omits and directly gives 2 and 4, if you enter the data directly like that, you will get a wrong answer. So you have to enter the equal time periods, especially years, and then your NPV formula of the calculator will directly give you the present value of all these future cash flows. Now in this case, if I want to check out, minus 1000 is in the first year, minus 500 in the second, 0 in the third, 4000, 3500 and 2000, and all these are discounted at 10% return. Now I can find out the NPV directly, especially when my cash flows are different for each of the years but equally spaced. I can directly use NPV where I'll give one interest rate and the list of all the cash flows. Even in calculator also we enter it like that itself. Then it says this entire thing is worth 4,711. When they are discounted at 10% every year, it is going to worth 4,711. Now generally what I suggest in this case is once you have the calculator, you try doing all these questions again. These answers should typically match. Right? The more we are able to match all these answers, the comfort level with the usage of the calculator is becoming better and better, right? So that's a better way to measure how much we are able to get the usage of the calculator, right? And of course, once everyone has it, we can very well plan out one session again using the calculator with the same set of questions itself, because these are the most common things where we are using all possible combinations, right? You don't need to give 1 2 3 4 5 6, only the cash flows. See, as long as they are sequential, you can very well just enter the cash flows itself. Yeah, it should be in the sequential order, equally spaced. Only then we can use the NPV. Let's say he did not give 3. I mean, here he has given it as a timeline and you are able to make out. Let's say he'll say cash flow at the end of first year is this much. End of second year is this much. End of the fourth year is this much. Third he did not give because he thinks 0 is not worth giving. So if that is the case, if you just enter them sequentially, the calculator will take whatever was the year 4's cash flow, it will take it as year 3's cash flow, where the whole calculation will go wrong. So intentionally you make it as 0 when you are entering the cash flows, so that it takes care of the timing accordingly. You don't need to give as 1 2 3 4 5 6. That sequence itself will take care of the 1 2 3 4 5 6. Oh, there's one more. So if at all I have so many cash flows, I just need to use the NPV formula, especially if I want the present value. It's better to use an NPV formula to find out those the present value of all the future cash flows. For future value, you have to take each of them separately. So which means you take the 1000 minus 1000 separately. Minus 1000 is the PV. 5-year or 6 years is the investment, or 5 years is the investment, because this is at the end of the first year and this is at the end of the 6th year. So end of the first year to end of the 6th year, there are 5 years in between. So my PV will be minus 1000. Then years is 5. Interest rate is 10%. I'll get 1 FV. Then take minus 5000 as another PV. The years is 4. Interest rate is 10%. You'll get another FV. So you'll get 6 such FVs. Yeah, the last probably 2000 you don't need an FV, because it is deposited on that day and it is maturing also on that day, because it is 0 years. So you can, at least the last one, you can keep it as 2000 as such. But for these 5, you will calculate separate FVs and you add them up. That is the only way you can solve future value of uneven cash flow FVs. Only for the present value, you have this tool of NPV. Right? For the future value, you don't have. Or the other better way is, you first find out NPV. Right? You first find out NPV. Then take this as the present value for a 6-year deposit. So I will get it as, I'll use the future value where my rate is 10%, years is 6 years, and this is the present value. Because I have brought all of them to the present value, and from there I am taking to 6 years later. I am breaking it into 2 problems. Either I should break it into 6 problems, each of them with a separate PV and then FV. Otherwise, by using NPV, I am breaking it into 2 problems. Getting all of that to today, from today taking it all of them as a bundle, I am taking it to the 6 years later, which is becoming 8347. Even if just to test out that number, I can very well go with, if I say FV, right? Here I'll take it as 10%. This I will take it for 5 years. So this is the FV. So this time period has to change. Okay. You see, it is coming out to same number. I take the FV of all these 6 numbers separately and add them up, which is coming out to the same number as I doing an NPV of that, and then taking that entire thing to a future value. Now so see, at the end the PV and FV are nothing but just the timing consistency, because all these payments are done at different points in time. As a part of the PV and FV calculation, I am trying to bring in a consistency to the timing, bring either all of them to today or take all of them to some future date. That is what is the intention of PV and NPV or FV. So if I want the future value, there is no direct future value formula in our calculator also. So one way is you break the problem into 6 problems and solve them separately and then add up, or break it into 2 problems, bring it down to the today's value, all of them using the NPV, and then take all of them as a bundle to the future after 6 years using a simple FV. It all depends on how we frame our problem. So that is where a construction of a timeline is a very important aspect in these problems. The more and more we are getting that efficiency in constructing the timeline, it becomes more and more easy for us to solve any kind of a complex problem. Right? We'll try to see a couple of problems again. Yeah, this is one more problem which we did not look at. Another application of time value of money is our loan amortization schedule. So just like I want to take a loan of 1 lakh for 10 years. Annual interest rate is 9% and I have to pay equal amount every year for 10 years. So which means numbers wise what? This is what is my PV, because I am getting 1 lakh today. That is what is the PV. This is what is the N, and this is what is the rate. And I have to find out that equal payment, which means I have to find out the PMT, annuity, because it's a equal payment, equal intervals of time. I have to find out the PMT. Now in this example, if I look at, if I just take it slightly down. So in this case, my PV is 100,000. Then 10 years and 9%. So interest rate is 9%. The N is 10. And I don't need to pay anything at the end of 10 years. My loan is cleared off within the 10-year period itself. So FV is like 0. I have to find out what is my EMI. So compute PMT, where I have to give this, not EMI, equated yearly installment, EYI, because I am paying as an yearly installment, not monthly installment. If I have to do it as a monthly installment, this rate has to become a monthly rate, divide by 12, and even the N has to become number of months. So which will become 120, 120. 10 years, 120 months. Alright, so this, then this is the number, then this. So it is saying I have to pay around 15,582 as my EMI, or equated yearly installment. Right? If I borrow a loan of 1 lakh for 10 years at 9% interest rate, every year I have to make an equal installment of 15,582, which means overall how much I am paying? This into 10, which is 1,55,820 is what I am paying. There is some portion of principal. The principal portion is only 1 lakh. The remaining 55,000 whatever is the composition of the interest in the process. So every year I may have to find out of this amount what is the contribution to the principal and what is the contribution to the interest. Because from a tax standpoint also, principal and interest are treated separately. Right? So my interest is taxed separately and principal is taxed separately, or the deductions which I get or the benefit which I get on the interest which I am paying versus principal which I am paying are different. So I have to actually find out of this that 15,582 is actually like a equal installment which includes some principal and some interest. So I have to break that. Every year the principal will different, interest will be different, because the interest will be on the outstanding principal, and anything above that is the principal payment. So the principal will keep coming down every year, because every year I am paying some portion as the principal in my installment. So my principal will come down every year. At the end of 10 years, that principal has to become zero, which means there is no more loan that is outstanding. All my loan including the principal also got paid off. That is what is typically called as a loan amortization schedule. Now how do I make that is, now here I will take them as year 1 to 10. I have to do it as a manual process itself. I'll take it as, at least from an exam standpoint, but he may not ask any of these. Generally, first year or second year, he'll ask what is the composition of the principal and what is the composition of interest. He does not ask up to 5th or 6th or 7th, because manually it is very difficult to make up to the 5th or 6th or 7th years. I have to, probably if I have a tool like this, I can do it for any number of period. But when we are doing with a calculator also, it becomes a repeated exercise, right? Okay, so if I say first what I do in that process is, first I will find out the interest, right? So principal, and then I will say principal balance. So which means out of the total principal, how much is left, because I am paying some of the principal, right? Now interest wise, probably let me take the positive side of this. Okay, interest wise, first I will compute it as the principal amount that is there in the beginning multiplied by the interest rate, right? Because today I have, when I have taken the loan, my principal is 1 lakh. So at the end of the year when I have to pay, the interest is applied on the whole 1 lakh. So the interest portion is 9,000. But in reality, I am paying 15,582 as a part of my equal installment. Which means the excess amount. How much? 15,582 minus interest is what I am paying towards principal repayment. So in the year I am actually paying 15,000. Out of that 15,000, only 9,000 is corresponding to the interest. The remaining 6,000 odd is corresponding to the principal, which means some portion of the principal I repaid in the first year. So at the end of first year, my principal amount has come down to this much. Out of 1 lakh, I have paid out 6,500. So my principal amount at the end of the first year is only this much. So which means in the second year, the interest of 9% will be applicable only on this. The 9% interest will not be on 1 lakh anymore, because the principal at the end of the first year is only 93,000, not 1 lakh. So my interest will be only this much. But I am still paying 15,582 because it's an equal installment. So which means in the second year, this much amount I am paying towards principal. So which means my modified principal is becoming this minus this. So my principal that is outstanding at the end of the second year is 86,000. Now the same way, if I want to do it in the third year, this is the principal that is there multiplied by this interest. This is my interest. So the remaining amount out of the total EMI whatever I am paying, the remaining amount is what is my principal. And then this year the principal balance is this much. The same way I do it all the 10 years. Now you see, by the time I reach the 10 years, we are seeing that the principal balance is becoming 0. Which means all my loan got paid off as a part of some installment. Now you are seeing that the interest wise, it has come down over the period because principal is coming down. But I am still paying an equal installment every year. Which means the contribution to the principal is going up every year. Right? It is going up in such a way that towards the end, it is becoming 0. This particular table is actually called as my loan amortization schedule table, which will give me a breakup between the principal and the interest payment, right, each year. So sometimes the question may be like, what is the interest that I have paid in the second year? I have to pay in the second year. Which means I have to do it for the first year first of all. The interest part for the first year, the principal part for the first year. First I have to find out PMT. Based on that PMT, first I have to find out the interest part for the first year. So the whatever the PMT value minus the interest part will give me the principal part for the first year. Deduct that principal from your total outstanding. So for the second year, apply that interest rate on that amount. That is how the whole calculation goes. Getting it? So this is so the question may not be complicated to 7th year or 8th year because you have to make for all 6 years in that case. But at the max, it can go to first year or the second year at the max. It cannot test you beyond that. But yeah, some understanding aspect of the amortization schedule, something like the interest. See, he may say which of the following statements are true. The interest rates keep going down as the period increases. the principal keeps going up, principal contribution keeps going up as the period increases. So some kind of questions like that would be more expected rather than some kind of lengthy calculation, because the exam never focuses on doing very long calculation. It majorly focuses on your understanding and comprehending ability of those questions. See, diminishing interest rates is again like your rate itself can go diminishing. There are again some instruments where the interest rate itself, let's say from 9%, it may go to 8.5%, then to 8%, depending on, let's say you are a very new company, you have a very big risk. So the banks might very well say that, yeah, now for the next 2 years you pay around 9%, but within 2 years we'll look at your profitabilities and all. And if you are becoming more and more reliable and consistent, we'll reduce the interest rate to 8.5 or 8%. That is diminishing interest rates. But this is diminishing interest values. The interest amount is getting diminished, because your outstanding principal is coming down every year. Right? So this is one major application of time value of money. Right? Because PMT is what we are finding out at the end. And from that PMT is found out through the time value of money itself. Otherwise, manually it becomes a very difficult aspect. That because it's an annuity, it's very easy to find out the PMT value. Otherwise, it becomes pretty tough. And if at all I have to do it as monthly payment instead of yearly payment, this interest rate will become 9% by 12, and this periods will become 120 periods. That's the only difference. Now, yeah, this is another thing. For how many years do I need to deposit 1,000 every year? If my target is to reach 10,000 at 10% annual interest. Now here I need to find N, which we did not find out till now, but the process is the same. My PMT is minus 1,000, FV is 10,000, interest rate is 10%. I need to find out N, compute N. So I can say my PV is minus 1,000. Sorry, PV is not minus 1,000. PMT is minus 1,000 because I am not doing it as a lump sum deposit. It's a deposit every period. My FV is becoming 10,000. N is what I have to find out, and the rate is 10%. So I can find out N with these numbers. Which is telling me that I need to deposit for 7.27 years. If I deposit 1,000 for 7.27 years, probably 7 years and a quarter approximately, then it will amount to 10,000 after 10 years. Or after 7 years, 7.27 years itself. That amount will worth enough 10,000. So in effect, I am depositing only 7,000 odd, but it will be equivalent to 10,000 because of the interest rate that it is carrying. So at the end, this kind of conceptual clarity is what it is expected in this. So this chapter is completely on the numericals itself. Yeah. Now this has actually multiple problems in it. The more you are able to break it down and solve it, you'll get a very comfort level in terms of doing it. This is the kind of a financial planning kind of an example. I'm currently 33 years old. So we'll draw a timeline. Currently 33. I want to retire at the age of 60. There's a 27 years old period. I want to earn 15% on my investment up to my retirement and 12% per year after that. So probably here, I don't know by how much period. Yeah, this is 22-year period after retirement. So probably I'm assuming that I'll be alive up to 82. So I'm putting a 22-year period after the retirement, some kind of benefit. And I'm saying during this period I need 12%. I want to withdraw a pension of $50,000 every year. So in all these periods, I want to withdraw 50,000 every year. Right? For a period of 22 years up to 82. How much do I need to deposit every year? Each of these years, how much do I need to deposit so that I can earn 50,000 every year? Now, if you are trying to see the problem, I can break it down. First, at this period, where I am seeing 50,000 every year, which means PMT is 50,000 in future. Every year I am getting 50,000 at 12% interest for 22 years. I can find out the present value there. Right? That's the first step. So let's say I'll find out what is the worth of all those 50,000 discounted for 22 years at 12% rate of return. So let's see the PMT. At the end, it's the same stuff. The PMT is, because I will be withdrawing 50,000, I'll write it as positive. This is the amount, and the N is 22 years. Because I'll first, as a problem, I'm shifting myself to that 60 years, which means 60 is actually the current period. When I'm assuming that I have already moved to 60 years. I'm positioning myself there. So the 60 is like today. Then I can look at it as an annuity of 22 years, where 50,000 is coming every year for 22 years at the rate of 12% interest. So I can very well find out what is the PV of this entire numbers. The present value of these entire numbers is working out to this much. The present value of that entire thing. So all those, which means if I have to get, the simple way to understand this is, if I have to get 50,000 every year for 22 years from my 60th year, at the end of 60 years, there should be an amount equal to 3,82,232 available in the pool. So my money should accumulate to 3,82,232 by the time I reach 60 years. Then that 3,82,000 can be distributed in such a way that I will get 50,000 per year for the next 22 years. So now my target is, from now, deposit some amount so that the future value at the end of 60 years will be equivalent to this 3,82,000. Right? So now I'll break the second part of the problem. I'll take the second part of the problem. This will become the future value. And my question is, how much do I need to deposit every year? So it's a PMT. PMT for 27 years, because 33 to 60. PMT for 27 years at 15% rate of return to accumulate that amount, 3,82,000. How much do I need to deposit today? So basically this one will become my future value will become 3,82,000 my interest rate will become 15%. My time period is 27 years now. And I need to find out what is the PMT in the process. What is the PMT in the process? Which will say every year I just need to deposit 1347. If I am able to deposit 1347 every year for 27 years, right? Overall, how much am I actually depositing? This into 27 if I do, I'm actually depositing 36,394. But because of compounding, this entire thing is becoming 3,82,000. So almost 3 lakhs odd is the interest because of the compounding, because we have put 15%, which is a very high number. So it is saying you just need to deposit 1347 and that will accumulate to 3,82,000 at the end of, by the time you reach 60, and that can be distributed at 50,000 per year for 22 years on your retirement. So this is the kind of a complex solution that I will build. This is a typical financial planning solution. How much you want as a part of your retirement plan, and based on that I try to work backwards and say this is the amount you deposit today. Now if this is the amount you want to save today, then I'll think of what plan is suitable for you. A typical financial planning world uses nothing but the time value of money itself in the whole process, right?